my course, Game Development Basics, Week 2, Lesson 6, Basic AI Implementation. In this lesson, we're going to define artificial intelligence. We're going to explain some of the Unreal Engine AI systems that are built in. We'll demonstrate creating an AI controller class and assigning it to our bug actor. And then we'll demonstrate AI movement. Artificial intelligence is any program that allows a machine to perceive, calculate, and make decisions based upon information provided. In game development, and specifically Unreal Engine, AI is used anytime an actor or a pawn is controlled by the game engine and is required to make decisions based upon the player's input or other inputs. The goal a lot of times is to simulate the decision making that a human or other entity would make to make the game more realistic and immersive. Unreal Engine has many AI systems built into it, and we're going to use a couple of them in this lesson, specifically the AI controller class, which can be assigned to a pawn and can take control of a pawn similar to the way that our player controller can. And the navigation system, which allows the AI controller to direct a pawn's navigation in a scene. There's many more AI systems built in: behavior trees, state trees, EQS, smart objects, perception system, the list goes on. If you want to learn more about the AI systems built into Unreal Engine, I highly recommend you read the documentation on this, as you can learn a lot just from the documentation. And we'll cover some of these other systems later in the course, but for now, I want to keep it really simple. We're going to create a controller and we're going to create a navigation system, and that will allow our bugs to move towards the player's tower. First, let's set up our AI controller. We can right-click and select Blueprint Class, and we notice the AI controller is not one of these commonly used classes. If we open the drop-down and type AI controller, we can find it here. So let's create a new blueprint from this class, and I'll call this Blueprint AI Controller. And if we open this up, we can see it has its own blueprint graph, which would allow us to create functionality for this AI. And then any AI that has this controller would have that functionality built into it. So if we wanted to have multiple types of enemies but have similar behaviors, we could create all the different enemies and have one controller class to control all of them. Let's go to our bug and we'll go to the class defaults. And here, under the pawn and the details, we do see that we have some AI information here. We can set the AI controller class now to our BP AI controller. And one thing we want to be aware of is that we're going to be spawning these AI into the world with our game mode. So we want to possess these actors with the AI when they're both placed in world or spawned into the world. Next, let's get the AI movement set up. And there's multiple ways to go about where we can implement this, but I want to keep it simple. For now, I'm just going to keep it on my bug class. This type of implementation would make sense if we wanted this bug to act differently than other AI, or if we wanted to have specific functionality for this bug that existed outside of the AI controller. Let's move these two events out of the way, and we're going to create a new custom event. We're going to call this Move to Tower. And if we drag off of here and we type AI Move To, we can see that there's an AI Move To node already set up for us. It takes a few inputs. The first input is a pawn, and this will be the pawn that is moving. In this case, we want to use self. So let's drag off here and type self and get a reference to self, because we want this actor to be the one that's moved. We have two different ways we can set the destination of this actor. We can set it by an actual location in the level, or we can set it based upon the location of another actor. For this implementation, we'll use the target actor, and this actor is going to be our player. So let's drag off of this and promote it to a variable, and we'll call this tower. But right now, the tower isn't set to anything. we need to set this variable to something, otherwise we're going to get a null, and this functionality will not occur. In our begin play, let's drag off and say get actor of class and select player tower. Now, this isn't the cleanest of implementations, but we know for our game there's only ever going to be one tower in the scene. And there should always be a tower because it's our default pawn and it's spawned by the game mode when the level is loaded. So although this may not be the best way to go about it, for our game we know that this will be pretty stable. We could take our tower and we'll do a set and we'll drag off of there and plug the return value from this get actor, which would be the tower that we found, into here, and we'll set that as our tower. If you wanted an extra check in here, you could also use an isValid macro. And doing it this way would check that after we get this actor, does the actor actually exist in the game? And if it does, then we'll try to set it. If it doesn't exist, we have another pin here that we can use for other functionality. So we could try to set it again, or we could simply do a print string and type out an error code that says no tower in level. And this would at least give us some debugging scripts to know that we didn't actually get the tower when we tried to. And we have our move to tower event, but this is never actually being triggered. So let's add that here after we get our tower. Move to tower. So now our AI is set up. It has an AI controller, and it has a basic AI to move to the player after it's spawned. There's one more piece that we need, and that's a navigation system. To get an AI actor to navigate within a scene, we need what's called a nav mesh. So if we go to our place actors and we just type nav, we'll get nav mesh bounds volume. Let's drag one of these into the scene and set the location to 0, 0, 0. And similar to our brushes, we have brush settings here, and we can make this much larger. Let's make it about the size of our scene, and that looks like maybe 6,000 by 6,000 by 1,000. And if we scroll out, that looks like plenty of room for our bugs to navigate. We can also press the P key and it will show us this darker green area, which tells us everywhere that the bugs will be able to navigate now. And the last thing is that our bug actually needs the ability to move within the scene. And here's where I found an issue. When we were creating the bug, we chose the pawn class, but the pawn class doesn't have the ability to move the character. We needed a character class. And this is no problem. We can easily fix this. Let's go to the class settings. And here we have a parent class, and we can just change this to character. And now we see that we have a new component called character movement that's been added because this is part of the base character class. Let's hit play and see now that our bug is moving towards the tower. There's one more setting in the AI move to, and that's the acceptance radius. This controls how close our AI will attempt to get to our target actor or to the destination. And this is 5, which is way too close for what we need. Let's set it to 200. Let's compile. And now we see that our bug is stopping just short of the tower, about the approximate distance that it would look like it had been attacking it. So in this lesson, we got an AI controller set up on our bug, and we got it moving towards the tower. But for our game, we want more than one bug. So in the next lesson, we'll talk about timers, and we'll set up some functionality so that our game mode continually spawns bugs into the level until the player dies.